In this video, we will look at selection pressures. Now, selection pressures are external agents which affects the organism's ability to survive. So they can be positive or negative. Positive means that we have an increase in the trait, and negative means we have a decrease in the trait. Just think about those beetles before. Positive, we're going to have more of the brown beetles, but negative, we're going to have less of the green beetles. So selection pressures may not remain constant. They can lead to change, which actually constitutes a beneficial adaptation. Okay, now there are types of selection pressures: resource availability, environmental conditions, and biological factors. So pause the video, have a read through this information. Okay, so selection pressures, this is quite a good mnemonic. It was called PANDAPOR. Now, for example, if we have density dependent factors like predators, availability of nutrients, nutrient supply, disease, and accumulation of wastes, we can have phenomena, abiotic factors, and weather conditions, which is the density independent factors. It's quite a good example of these selection pressures. Okay, so what we're going to do is look at types of selection. Now, there are always going to be more numbers of favorable phenotypes within a population, okay, because they have more successful chance of reproduction, therefore are going to pass their alleles on to the next generation. Now, we can basically look at a graph looking at the phenotypic frequency, like this one here. Now, we can see here that it's a normal distribution curve. We have the majority of the phenotypes in the middle here, and less frequent ones on either side. So basically, let's look at the example here of cats. Small cats, there's not many of them. Large cats, not many of them as well. Medium cats, most feline domesticated cats, we have this medium size here, or the higher frequency of them. Okay, so there are three ways that natural selection can cause this normal distribution to change. So some of the times it will not look as perfect as this does. It can actually change due to natural selection. So the first type is called stabilizing selection. Now we can see the dotted line here would have been our original population. But if we have something that is selecting for those organisms, okay, we're going to have a reduced number. Therefore, we're going to have more of these middle ones here. Okay, so for example, we have an organism that was a particular color, this one and this one. Okay, they stood out more than this type. Then we're going to have an increase in this type, maybe because it's camouflaged more. The next type is directional. So the original population, as we can see, we may have a selection against an extreme on this side. Okay, therefore the population is going to shift over. This whole graph shifts over. The third type is called destructive. Okay, as we can see, if we have selection against the mean or the middle of the curve here, the population, we have two humps. Okay. So this explains it in more detail. Feel free to pause the video because there's some examples with the butterflies and the color here. Okay, so in summary, stabilizing selection, pressures select against two extremes, directional selects against one extreme, disruptive selects against the middle, and those are the three that you need to know about. And that's the end of the video.